tomorrow's. Today, it's about AI, which is, of course, a hot topic, as you imagine. And I will now present the participants to the panel, and starting with Ana Cristina Bicharra Garcia, who's full professor at University Federal do Estado do Rio de Janeiro, Unirio, whose main interest is currently is about ethics for artificial intelligence. I won't detail all the information about the participant, because you also have information on the web, on the website. Just shows a few characteristics, right? So next is Fabio Cozman. Fabio is also full professor at Universidad de São Paulo, and is head of the C4AI, which is Center for Artificial Intelligence, which is from a USP and joint with IBM and FAPESP. And his interest is diverse, various things, but application also, especially question of uncertainty handling. François Pachet is head of Spotify's Creator Technology Research Lab in Paris, which was recently created. His main interest, since I know him for very long, is about AI and music, and especially music co-creation, as he will explain. Priscila Machado Vieira Lima is professor at Universidad Federal do Rio de Janeiro, and she's interested in, of course, in AI, as all of us, especially in neural networks, and also in the issue of education and demystification of AI. Stuart Roussel, last but not the least, is professor at the University of California at Berkeley. He's one of the first author of really the standard text book in AI, Artificial Intelligence, a Modern Approach, that is very widely used in most of courses about AI, and his most recent book and his current interest is about compatibility between human and AI. Of course, a big question. And myself, so my name is Jean-Pierre Briot. I'm also from France, like François, except that I have a foot also in Brazil. I'm a directeur de recherche from CNRS, Centre National de la Recherche Scientifique, and also at Sorbonne University in Paris. My interests are also about AI, and recent interest is on a project for AI support for participatory management, decision-making for biodiversity, especially protected areas. And with Marta Irving, who's professor at UFRJ and who was the coordinator of previous panel last week about biodiversity and sustainability. And I'm also, like François, interested in music. So just a slide to thank, in the first place, Ana Célia Castro, who's the head of Colégio Brasileiro de Altos Estudos, da UFRJ, and who's the maker, the designer, and the chief of this conference. So really thank you, Ana Célia, for making it possible. UFRJ was actually 101-year anniversary. So the conference was supposed to be last year, but because of the pandemic, it was rescheduled this month, and through internet. I want to thank, of course, the participant to this panel, Iago Paiva, who will be the moderator of the questions from the audience through YouTube, the translators, who are doing great job, and so let's start. So the idea, at first, I should confess, I thought I would be lazy, as I like to be. that is do a minimal introduction, basically present that's done the participants to the panel, but and that's it, and let the debate go on. But I thought that it would be useful to give the audience and everybody some kind of shared background about AI, about history, terminology, and main concepts, to be able to have a kind of minimal information and background. So I'll try to do it now, and of course it's a challenge. So why a panel about AI? Well, I think it's obvious. It's omnipresent. For instance, most of you have a smartphone. On a smartphone, probably there's some personal assistant who can recognize your voice, who can help you. You heard, of course, of the cars without human driver. Of course, the robots, they are not only in industry, but also they are more and more at home, for instance, to take care of elderly people. For instance, in Japan, this is a big issue because there are a lot of elderly people in Japan. And of course, there are good news and good application, and also there are some fears, there are some concern about the future. So let's give this kind of introduction background. So at first we'll start with history, because of course to understand the present and the future, you need to know minimum about history. So the term artificial intelligence was actually introduced by a few number of researchers, mostly coming from mathematics, because computer science is very recent, actually, led by John McCarthy and a few others. Claude Shannon, for instance, is the father of information theory. It was in 1955, so quite a long time ago, and they basically applied for money, a bit of money, to organize a workshop for brainstorming to think about intelligence, human intelligence, and how to model, to study, and to simulate it with computers. And it was based on the conjecture that computer should be able to model and to describe and simulate lots of, maybe quasi all aspects of intelligence. So of course this is a very, very ambitious objective, and also one of the possible impact is, of course, not only understand to do it better for computers, but also to have some feedback about human intelligence. So it's very ambitious, and what is important to point out that actually they created, especially McCarthy and Minsky, this new term artificial intelligence, because they wanted in a way to create a new stream of research, distinct, independent from cybernetics and from connectionists, especially. So what is cybernetics? It's a study of self-governance. Actually, it's very, even before Norbert Wiener, who was one of the main person about the cybernetics movement, which is about feedback mechanism, a system to auto-control. Actually, Plato, the Greek philosopher, famous Greek philosopher, already talked about cybernetics. It's a Greek word. In his book, famous book, République, and because it's about self-governance of a citizen, actually. Connectionism is the inspiration from the brain, from biological neural networks, to make some artificial neural networks mimicking partly the human brain, and to do some pattern recognition tasks like face recognition. So they actually wanted really to ground their this new field. Actually, it's important to point out that as well. with a strong foundation in concept, in logic, reasoning, etc. So we speak usually about symbolic artificial intelligence, as opposed to, for instance, connectionism, as we will see. So, of course, the term artificial intelligence triggers a lot of debate, even now, and there are some researchers who say no, it's a bad term. They shouldn't have created this term, but anyway, that's done. Okay, we have to go with it, whatever you like it or not, and because it creates confusion, ambiguity, etc. Maybe anyway, it will remain still there. Although, for instance, you could use another the same acronym AI for augmented intelligence. That's, for instance, what Luc Julia is proposing, some researcher. But actually, augmented intelligence also existed, and it was the term was created shortly after the creation of the term artificial intelligence in '62 by Douglas Engelbart, who's one of the big of another big guy in the field of computer science and AI. And who was the pioneer of mouse, using a mouse. Now everybody has a mouse, graphic user interface, hypertext, etc. And which led way to Lisa computer from Xerox, after Macintosh, everybody knows, from Apple, and MS Windows, Microsoft Windows. So artificial intelligence really focus on the modeling of reasoning for an autonomous artificial agent, which could be a software, it could be a robotic. At that time, this was a very, very, very simplified type of task, which was simulated for a robot. There were only a few very simple robots. Now you have humanoids robots, for instance. And augmented intelligence, the focus is on assisting humans. So actually, for instance, again, like the personal assistants on your smartphone. So actually, of course, these objectives are complementary. They are not in opposition. So now, let's get to a first definition of what would mean artificial intelligence. Actually, I take the definition which from the book of Stuart and Peter Norvig. AI is about building machines, so it's about building, not just thinking about and designing, but actually constructing. That do the right thing, that is that they for instance, they won't kill people, etc. This will be one of the topic of Stuart's presentation, that act, so they do things in ways that can be expected. That is also, we could, and in a way, explain somehow, would like to be able to explain, to reflect, and to on what and why they do this to achieve their objectives. So it's a So going back to this little bit of history with McCarthy and a few other who created artificial intelligence based on the concept and logic, I also introduced briefly subsymbolic connectionist AI based on the imitation of more basic mechanisms of the brain for visual and audition pattern recognition, for instance. So actually, the two are very different. The first one, the first stream, symbolic AI, is more inspired from the reasoning from the prefrontal cortex, and some applications are expert systems, for instance, used for e-commerce, decision support systems, robotics, games, etc. While subsymbolic AI is based on mostly statistical data machine learning, and it's more inspired by the more basic processes in the brain for visual, for instance, recognition. So they are named one of the main technique stream within this subsymbolic stream are artificial neural networks and Now they are called deep neural network, deep learning. And I will talk about that in a minute. And they are very good at face recognition, voice recognition, but as well robotics, games. So in a way, you could think, wow, robotics and games are both symbolic AI and sub-symbolic AI. They're addressing the same kind of applications partly. So they are in competition, which is true, but also they are very complementary. Let's take some example. As this is a conference in Brazil, let's take some soccer game, but football, but played by robots. There's a competition named RoboCup, which exists for more than 20 years. And with different levels of competition, with robots with wheels, humanoids, robots of different size, etc. So a robot, it needs to be able to plan ahead to what it will try to follow the ball, or to for instance, to block attackant if he's a striker, and also to coordinate with other players of his team in order to have some strategy which could be predefined or defined on the spot, and to make some pass and to construct attack or defense, etc. At the same time, it also needs to do some more basic things like looking at recognizing the ball, also the adversaries and the colleagues in his team, to do some motor control, to be able to walk, to kick on the ball, etc. So actually, you really need the two streams, the two dimensions. They are really complementary. And just this little slide to show, I'm using always the same color code. So the symbolic stream is in blue, and the sub-symbolic, including deep learning, is in orange. So this is what does this show? This shows the comparative impact in terms of publication, number of publication of the symbolic research or the sub-symbolic research. And you could see that first the orange, that is the sub-symbolic, with works like Perceptron, the first artificial neural networks, was very prominent. And after, at some point, especially after the creation of the artificial intelligence movement by McCarthy, as I said at the name, the blue became prominent. And from the mid of 90s, it's reversed again. And now there's more prominence for the sub-symbolic, especially the connectionist, the artificial neural networks movement, especially with deep learning, which are really very, very big at this time. So one of the question you may have asked is what is the relation between AI, artificial intelligence, and deep learning? I guess that everybody at least heard about the two names. So how to relate them? So you have to think that you have to understand that AI is very big. It's a big field. There are many sub fields and sub tasks. For instance, coordination between soccer players, planification, reasoning, etc., decision making, and learning. Learning, why learning? Learning is for acquiring knowledge from experience to improve behavior. Okay, perfect. And learning, actually, it's a field on its own, because you have different kind of learning. I won't get into details, but one of this subfield of learning within machine learning is statistical data learning, and deep learning is within it. This artificial neural networks is this, and it became huge, as we will see. It became huge. So the paradox is that deep learning is just one kind of learning, which is one kind of task and objective and technique within the bag of concerns and techniques in AI. But the paradox is that deep learning is so big that for many people, deep learning is bigger than AI. So which is actually, which should be the reverse, which creates this confusion. So why is it so big? Because it's very efficient at doing a face recognition, signal processing, signal recognition, for instance, speech and speech generation as well in the personal assistants. And also you heard maybe about AlphaGo and the games. I will just speak shortly about it. And the techniques, the basic technique is very simple. I won't get into technique and details, but just let's think these are actually layers of neurons, of almost human neurons, human brain neurons. You recognize, you are looking at a picture of a dog, for instance, and the neurons, they activate, they propagate the activation until at the end of the network, you have some neurons, each one corresponds to some class of animal you want to recognize. Cats, for instance, dogs, elephants, etc. And the ones which has the stronger activities, the most likely, most highest probability that this class has been recognized. So for instance, if the cat neuron at the end triggers, that's wrong. So in the training, we'll have to change a little bit the connection between the pseudosynapses and again with different examples, as for the network to be able to recognize properly dogs and say, okay, it's a dog, image of cats, and it's a cat, etc. So it's a very, very simple, and actually the basis is logistic regression, linear and logistic regression, if you remember of the basic mathematics. If not, don't worry. Why deep learning? Deep because you have many layers of abstraction. For instance, this layer, there are many ones. And I guess that somebody left his microphone open, so please could you hold the microphone? Could you? Thank you. Okay, so in our brain, you have a pipeline of the same type of various layers of neurons, for instance, to start from a vision, to recognize more and more abstraction, and to make some decision, for instance, to move the hand. So another reason for success is the computing power, which is cheap now, and also the data is cheap. You heard about you now. More important, some people say more important algorithms, more important is the owner of the data. So actually, with all of this, it becomes very, very powerful, very efficient, and with very much success. So of course, because of the success of AI, it creates a lot of fantasies. You have lots of movies, a few which are very science fiction movies. A few are very interesting. Most of them, I guess, are not very interesting, but some of them, they are more profound because they in some sense, they explore future scenarios, and which is more interesting. And of course, this creates our human beings to ask ourselves questions like, will machines eventually become intelligent? Will them be able to have a mind, to be conscious, to think, to create, to love, suffer, etc.? And some people say yes, for instance, Ray Kurzweil. Some people say no, a computer will never be able to do so. So I will just try to give a few clues to address this kind of question, which is, of course, makes sense. So at first, you have to decide what is your model, what is your assumption about intelligence, about thinking, etc. Because we have, as human beings, we are too much anthropomorphic. That is, we tend to view everything through our human glasses. So at first, you could consider that only human can think, is intelligence, and animals and machines are just, they don't have mind. They cannot think. They are not intelligent. That's, for instance, what Descartes thought a while ago. and is basically is two main arguments. But of course, now we consider that animals, especially primates, who are our cousins, could also be intelligent. So look at this video. You have some person who make a kind of magic trick to this orangutan in the zoo. He has removed the little fruit. And you could see from the reaction of the orangutan that. So how do you interpret that? That he really understand? He's laughing. He understood the trick or not? Of course, it's difficult to have a complete, definite answer. But this is true that now we are more and more discovering that animals, especially, for instance, another animal which is very, very intelligent is the octopus. If you the documentary which won the prize, best documentary in the Oscar, was My Octopus Teacher. I really deeply recommend it. Very interesting, and it's cephalopod, which it's a Greek word. It means that lots of part of his brain is actually within his legs. So this means that he has a very different way of apprehending and moving and modeling the world as we do, because he's built in a completely different way. And computers, of course, are built also in even more different way. So just one more talk about animals. For instance, crows. There are some experiments where crows are being able to make tools by themselves, to bend some wire in order to retrieve food. And even a blob, which is a very, very simple monocellular, imagine an organism which is just one cell, which could be with kernels which could be replicated. Without any neuron, it can move, it can learn, it can communicate with others and do some optimize a path to look for food. So this means that there are other ways of being intelligent and adaptive, and depending on how do you define it, and not necessarily having our kind of our brain. So of course, how can we predict and envision machine being intelligent? Turing, who's one of the big researcher in the history of computer science, put it himself in 1950. The only way by which one could be sure that a machine thinks is to be the machine and to feel oneself thinking. So we need, in a way, to get out of our human skin and human vision. So time is running. So just maybe how to evaluate AI. That's it's almost done. Huh? Don't worry. Evaluate AI. It's important. We need to have some kind of at least partially objective way to evaluate it. So one way was designed by Alan Turing. Turing, who did also the machine which resolved during the war, Second World War, the Enigma code of the German. And I don't know if you saw the movie Imitation Game. It's very interesting. Imitation Game was the name of the game designed by Turing. So the idea is very simple. You are, for instance, I am the evaluator, and or you are in a room, and in the other room, with just a little hole to pass some text from a room to another one, there's either somebody, a human being, or a machine. And you pass a list of questions, and sometime a list of answers written come back, and you have to try to guess if actually this is a human being or a machine which answers your questions. So that's the idea, and this idea is actually very much used. For instance, if you want to access questionnaires or lots of sometimes you get a CAPTCHA, which is some kind of test to filter from software robots in the internet, in the web. And actually, CAPTCHA comes from completely automated public Turing tests. So that's the same idea, to tell computers and humans apart. It also reads as capture, as capturing. And actually, one thing interesting is that at first you had to enter some, usually some names, which is with some deformation, some writing, or some recognize some pictures. But mostly now you just click, and the way you click actually will make the evaluator actually discriminate between your way of moving the mouse and clicking different from a robot. So you can use this test to, for instance, in some task like creating music, for instance, generating music in the style of Bach chorales, that is 4-voice based on counterpoint music. So let's just have a look at it. Oops, it's not working. Well, if it's not working, no problem. Let's, maybe it's because I need to check. Okay. Yes, now it's working. Okay. So it's a Dutch channel, and this is a Turing test. So there's a public and expert on the left. This is a Dutch channel, so they are speaking Dutch, obviously. Don't worry if you don't understand Dutch. And so the idea is that.
Okay. Yeah.
So the singers, the choir is singing some music, and the public and the experts need to try to guess, if this is from Bach, the music, or this is from the system, from the AI. So everybody will vote.
We kijken
even naar het publiek.
Ik zie
overwegend
Bach, maar een kleine minderheid zegt de computer.
Ja.
Kortom,
the expert, for instance, the expert on the left will vote for Bach. And the answer is reverse Bach. And then it goes on, and new music is, etc. So this is a way, to evaluate evaluates basically just the way a machine can imitate, but it doesn't make any assumption about the way it does. Another way to evaluate are games. A game between a human being and a machine. So of course you heard about Kasparov defeated by a machine, Deep Blue, in '97. And more recently, a Go game with AlphaGo. And actually, this program, AlphaGo, at some point it made a move that the human experts in Go, thought this was a big mistake, and finally it led to the victory. So in a way, the program AlphaGo was creative, that it explored and it found it a good move. A move which the experts thought that it wouldn't lead it could never win to the victory. And you may say, okay, games are games, okay, but what's the most more applied, useful? Actually, it's a way to test the potential, but. For instance, these kind of techniques have been reused partly to solve the problem of protein structure prediction, which was actually a big challenge for more than 50 years. So what's the point? What's the interest? Why is it important? Because the form of protein actually dictates its function. For instance, I guess you heard about the spike protein of the infamous COVID virus. And so actually to be able to predict the form of a protein from its components is very important. It's a way to be able to design new drugs, for instance. So just to finish this discussion, and it will reoccur probably during our debate, is the arguments in favor or against artificial intelligence. One of the common argument is it's only a machine, so it could not think like us, etc. It's only a machine, yes, but we are also a machine. So this is the counter argument. Of course, we've made of cells, of biological cells, and not of circuits. Programs are deterministic. This means that they will always lead to the result which could be predicted from actually the program, as they will do only what programs say them to do. Okay, but this is not always the case, because there's a lot of probabilistic reasoning and evolutionary mechanism in modern AI. And actually, this is the same kind of argument which has been used about 200, 300 years ago, saying that if you could know all the position and the velocity of all particles, you can actually predict exactly what will happen next. That is, there will be no more free will. Everything will be already predestined. And of course, this is not true. And quantum physics showed it. And another argument is saying, okay, this is good. This makes success, which is true, but very, very specialized machines and systems, which is also very true. But as I tried to show you with AlphaFold, with the protein prediction, it could lead to more general progress. So and there are still big challenges like the common sense, the basic mechanism that is self-evaluation, self-motivation. It's very important, self-motivation, to not just do what we want the machine to do, but the machine to do its own motivation system, actually, to have its own motivation system, self-organization, self-evolution, to be able to explain what is doing and why for him and for us. Of course, this is also very important. That's it. These are some references. Of course, everything is recorded, so you could replay at any time this panel. And now I will probably there's no time for the panelists to comment right now. Maybe later. But if they want to comment on my slides, and let's start the panel. So the idea of the panel. To favor time for debate, we discuss within us, participants, of the panel that to structure in three blocks. The first one being about AI and human compatibility and ethics. Second, about creativity, and the third one about myth and mystification. And for each one, there will be somebody will initiate the debate, and there will be debate between panelists, and a question. We'll take some questions. So you can make questions through YouTube, through the chat of YouTube. We'll try to answer a question, but of course, depending on number of questions, we cannot guarantee that all questions will be answered. And let's start with the first block, and Stuart will be the first to introduce this the topic. So it's about the collaboration between human being and machine, robot, and how to enforce that the machine acts appropriately, that is, understands and in a way affects our real intention, is also conformant to ethics. That's the topic that Anna Cristina will touch upon right now. So I'm done. Thanks a lot. Sorry for being long, but I think it was probably, well, I hope useful. And now I will unshare my screen. Yes, that's done. And Stuart, you can start. Sorry to be long. I'm always too long, I know.
Okay, thank you very much, Jean-Pierre. That was a great introduction to many important questions about AI. I also want to congratulate the university on its 100th birthday, a little bit late. It's a wonderful achievement. So let me talk about this question of compatibility between humans and AI. And by compatible here, I really mean, is AI compatible with human existence? So let me once again bring in Alan Turing, who Jean-Pierre described. So in 1936, Alan Turing wrote the paper that was the foundation for the entire field of computer science. So he created the mathematical basis for general purpose computation. And quite a few years before the Dartmouth workshop, he was talking about AI. So the paper in which the Turing test appears is from 1950, but even during the war, and certainly in his published work in the 1940s, he was talking about the possibility of artificial intelligence and how to achieve it. And most of what he writes is optimistic. He talks about what it could be used for. He talks about how it could be achieved. But in 1951, he gave a talk on the radio, and he said the following: "It seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. At some stage, therefore, we should have to expect the machines to take control." So he doesn't offer any solution to this problem. He doesn't really offer any apology, just a sense of resignation. He just sees this as the inevitable outcome of the field whose existence he is mainly responsible for. So the question is, why? Right? Why would the machines be taking control? How would this happen? How is it that making AI better and better could have this potentially disastrous outcome for humanity? And I think the reason why it could happen is built in to the standard model of AI. And in fact, Jean-Pierre quoted something from the most recent edition of my textbook, that a machine is intelligent to the extent that its actions can be expected to achieve its objectives. And that's exactly what I mean by the standard model. And in the most recent edition, I go on to say, I don't think this is the right way to think about AI, but this is the way that we have been thinking about AI since the beginning. And I think this is the way that Turing thought about AI. That we build machinery that is designed to optimize some objective that we specify from the outside, exogenously, meaning from the outside. And this standard model is not just AI. The field of control theory, which is what runs your washing machine and flies jumbo jets and manages chemical plants, uses the minimization of a cost function as its fundamental principle. In statistics, you try to minimize a loss function, which describes how well your statistical estimator will predict future data. In operations research, you maximize sum of rewards, or you minimize the sum of costs for complicated sequential decisions. And in economics, you maximize utility or GDP or social welfare or corporate profit. But in all these disciplines, the idea is that the objective is fixed and known and specified, and then the machinery takes over and does the work. And the difficulty is that we don't know how to specify our objectives completely and correctly. We can do it easily for games like chess and Go because the objective is built in to the definition of chess. You can't play chess unless you know that you're trying to checkmate your opponent. But in the real world, we don't know what the objective is. And the self-driving car companies have been spending years trying to write down what is the objective for something as simple as just driving from A to B. But it's not just going from A to B, it's going from A to B safely. It's going from A to B fairly quickly, but not too quickly. What exactly does that mean? Going from A to B politely, not cutting off other drivers or blocking the road unnecessarily, not shaking up the passengers, not frightening the passengers by having lots of near misses with other vehicles. And the list goes on and on and on. And we don't even know how to do it for driving, let alone running a corporation or managing the world or a nation or a university or whatever it might be, or an individual human life. And we've known that we can't do this for thousands of years. And every culture has a legend somewhat similar to the King Midas story. So King Midas is a legend from ancient Greece where the king says, it's a very greedy king, I want everything that I touch to turn to gold. And the gods grant his wishes. And of course, you know what happens next, right? His food turns to gold, his water turns to gold, his family turns to gold, and he dies in misery and starvation. And that's because he specified his objective incorrectly, and the machine, in this case the gods, carried out the objective that was given. In Goethe's story of the Sorcerer's Apprentice, the apprentice tells the brooms to fetch water, but doesn't exactly specify how much water and when to stop, and has to be rescued by the sorcerer. And if you ever find one of these magic lamps where the genie grants you 3 wishes, well, your third wish is always, please undo the first 2 wishes, because I've ruined the world. Right? And this story occurs over and over and over again in every culture. And I want to point out here that although the question of consciousness in machines is a very interesting one, and at the moment a completely unanswered question, we have absolutely no idea how to make one, how to tell whether we've made one, what to do about making one, no idea whatsoever. But in fact, for this point and for Turing's point, it doesn't matter at all, right? The only problem that we're concerned about here is competence and not consciousness, right? And a machine can be competent without being conscious. As we see, we assume that AlphaGo is extremely competent at playing Go, but we don't assume that it's conscious. And it doesn't matter, actually, whether it is or not. It still plays the right moves, and we play the wrong moves, and we lose. And this is the sense in which we're concerned about further progress in AI leading to a loss of control. So this is what Alan Turing is talking about. And we're already starting to see this, right? If we look at what's happening in social media, the algorithms that decide what billions of people read and watch every day, these are algorithms that have more control over human cognitive input than any dictator ever had in the history of the world. These algorithms are designed to maximize some objectives, such as click-through, the probability that you click on the next item that they send you. They also try to maximize engagement, how long you spend watching a given item, and so on. Or just maximizing sales if they're recommending books for you to buy. But they're all trying to maximize some fixed objective that's set by the corporation. And you might think, well, that's not so bad to maximize click-through. They have to learn what people want. And that's better that they send me news stories that I'm interested in than to send me news stories that I have no interest in whatsoever. But in fact, this is not how to maximize click-through. The way to maximize click-through is to modify people to be more predictable. Because the more predictable you are, the higher the click-through rate is going to be. And rather than just learning what you want, I'm going to change you into a different person, a person whose tastes and responses to content are more predictable than you are right now. And it turns out, apparently, that this means turning you into an extremist of some kind, whether it's a neo-fascist or an eco-terrorist or whatever, right? The machine doesn't care, the machine doesn't know, the machine just is measuring your predictability and maximizing it. And this is already having really quite disastrous consequences, despite the fact that these are really simple algorithms, right? They're not complicated, they're not doing super psychology or anything like that, right? They're just learning what kinds of content can change people in the direction that they want to change you. And in fact, if the AI systems were better that these companies are using, the outcome would be still far worse, because they will be much more effective at modifying people and turning them into very reliable and predictable consumers of the content that the companies want to send. So the fact that improving AI results in worse outcomes suggests that we got something wrong right at the beginning, right? That the whole approach, the standard model, is in fact the wrong way to approach building AI altogether. So I've proposed in the book a different way of thinking about AI. We call it Provably Beneficial AI. And in a sense, the robot does have an objective, which is to satisfy human preferences. And by preferences here, I don't mean just what kind of pizza you like or what kind of books you want to read. I mean which future you prefer, right? So lay out everything that you care about for as far into the future as you're interested in, and how would you rank the different possible futures? What is it that you want the future to be like? So this is what I mean by preferences. And the machine's goal is to be beneficial in the sense that it helps us to achieve the preferred future. But the key point here is that the robot knows that it does not know what those preferences are. And this turns out to be the thing that actually allows us to retain control. And briefly, the idea is that if the machine knows that it doesn't know what we want, then it has to pay attention to our instructions, because those instructions, those requests, our ability to, for example, unplug the machine, all contain useful information that will help the machine to satisfy goal number one, right? When we turn these principles into a mathematical problem, we call it an assistance game. So it's a game, that's a term from economics. It just means a decision problem with two or more entities. And here, there's at least one human and at least one machine. And they're part of a joint problem that we're collectively trying to solve. And we call it an assistance game because the machine is constituted to be of assistance to the human in this game. And when you solve these mathematically defined assistance games, the solutions behave exactly the way you want. The machine defers to human instruction. It will ask permission before taking an action that might affect the world in ways that it's not sure are desirable to the human, right? So for example, if it comes up with a solution for climate change that restores the carbon dioxide in the atmosphere, but changes the oceans into sulfuric acid, it might ask us first. If it doesn't know our preferences for the oceans, it's going to ask us before doing that, because it doesn't want to violate human preferences. So it's going to ask for permission because it doesn't know what it is that we want. And in the extreme case, we can show mathematically that it will always allow itself to be switched off. Whereas the machine that's pursuing the fixed objective will never allow itself to be switched off, because that would prevent the achievement of the fixed objective. So with this model of AI, we find that the better the AI system, the better the outcome is going to be, because it's going to be better at learning what our preferences are, and it's going to be better at actually supporting the future that we want. So we have a lot to do with this new approach to AI. The first thing we have to do, which is not written on the slide, is actually rebuild all the technology that currently exists in the field. Because every chapter of the textbook begins by saying, okay, for this kind of AI, here's how we specify the objective, and then here are the algorithms that achieve the objective, whether it's logical planning or machine learning or reinforcement learning or game playing. They all have this basic standard model, and we have to replace it with a new model, new technology, new algorithms, new theorems, new complexity analysis, everything. We also have to worry about the fact that the decision situation that the AI system is going to find itself in is actually a pretty complicated one. It's going to have to make decisions on behalf of not just one person, but many people. And of course, as soon as you're in that situation, you run into all the questions that moral philosophers have raised over literally thousands of years. One of the natural sort of quantitative approaches to making decisions for many people is the utilitarian one, which basically says, add up the preferences, right? Each person's preferences count the same, and make a decision that, in some sense, maximizes the sum of everyone's preferences. And this is a common approach in welfare economics, for example. And there are axiomatic theoretical foundations for why this is a good idea. But many other philosophers disagree with utilitarianism, and they point out all kinds of bugs that can arise and require making the theory much more sophisticated. And of course, the AI system is actually going to implement some form of moral philosophy. And the question is, what exactly should that be? Is utilitarianism enough? Or, do we need something more than that? Another important part of this research has to do with the fact that we need to learn about human preferences. And the source of information for what people want the future to be like is essentially the choice behavior that humans exhibit. The choices that we make, the choices that we don't make, the things that we say. We could say, I want X. That isn't proof that you want X, but it's certainly evidence that perhaps you want something. The difficulty in interpreting human behavior comes from the fact that we are imperfect. We are not perfectly rational. And therefore, the connection between our true underlying preferences for the future and our behavior is a complicated one. And it's impacted by our computational limitations, the fact that we can't choose perfectly. So a chess player, Garry Kasparov, I assume that he wanted to win those games, but he played losing moves against Deep Blue. So how could that be? Right? Well, the answer is because he's not perfect. And so to interpret his behavior, you have to understand the ways in which he's not perfect, because you wouldn't want to infer that Garry Kasparov deliberately lost the games. So that brings in lots of psychology, lots of cognitive science and neuroscience to try to invert our cognitive architectures to get at the true underlying preferences, to the extent that they even exist and to the extent that they are stable. So let's assume that we solve all these problems, right? Let's assume that we have AI that remains under human control, that is increasingly capable. If you have general purpose AI, what can you do with it? The answer is you can do anything that human beings can do by definition. And one of the things we do is produce our civilization. So that means that with access to more intelligence on tap, if you like, we can create a much better civilization. Many things have been converted from extremely expensive and difficult undertakings into basically instantaneous and almost free services. For example, travel. If you wanted to go to Australia 2 centuries ago, it might cost you the equivalent of $1 billion in 10 years, would require thousands of people, and you'd probably be dead by the time you got there. But now you take out your phone, you go tap, 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 and you're in Australia tomorrow, except they won't let you in, right? So that's what I mean by as a service. And general purpose AI gives you everything as a service. You know, your village needs a school, tap, 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 tap. You have a school the following week, right? So, so this would allow us at least to bring everyone on Earth up to the kind of level of quality of life that our existing technology already supports. And just bringing someone to, let's say, the 90th percentile standard of living in OECD countries would give you about a 10-fold increase in the GDP of the world, right? So this is not science fiction. We're not, you know, inventing super space travel or eternal life or any of those things. This is just using AI to deliver the quality of life that we already know how to deliver. And this has a net present value of $13.5 quadrillion. So that makes the amounts that people talk about, you know, investing $1 billion for AI or €1 billion for AI, right? They're absolutely negligibly tiny amounts of money compared to the value of the prize that comes from general purpose AI. You know, and additional things we could have beyond just what we already have, except making it available to everyone, would be, for example, high quality individualized education. We know that a really high quality human tutor can deliver education at a rate roughly 3 times the rate of regular classroom teaching. So very crudely, you could think of bringing a 10-year-old to the level of a college education. So that's what you can do with an individual human tutor who's very skilled. But of course, we can't afford a highly skilled individual tutor for every child. That will never be possible. But we can afford an AI tutor for every child. And so we could deliver extremely high quality education to everybody on Earth for almost no money. We could also use AI systems, and I think this is part of the picture of everything as a service, is that most of what we currently call work will be done by machines. And I think if general purpose AI comes about, this is an economic inevitability. And the question is, what does that mean for the human race? And it's hard to find a really positive answer. Here's the answer from Wall-E, right, where the machines run the civilization. It's a sort of intergalactic cruise ship that everyone is on, and they're all just passengers. All the humans are just passengers on the ship. And this cruise goes on forever. And they seem happy, but is this the future you want for the human race? I don't think so. And so this is really a cultural problem and a problem of imagination. What is the purpose of human life on Earth? Right? Is it just to struggle? Is it just to fight against scarcity and adversity? And then when scarcity and adversity have gone away, there's nothing left for us to do. I hope that's not true. We've been trying to run the World Economic Forum. You know, we're trying to run a competition to get people to imagine a future where we have as much AI as we want, right? Where AI is doing all of the work. And then what is the function of humans? How do they live their lives? What's the purpose? And that, you know, you can see why this is a real issue. Right now, we all get educated. It's a very long, expensive process. I estimate that the human race over its existence has expended 1 trillion person years in teaching and learning. 1 trillion person years. So that's a lot. And we've done that in order for our civilization to continue, because if we didn't, it would stop. But now we don't have to do that anymore, because we can teach the machines and they can run the civilization for us. And in that case, the major impetus, motivation for learning and education of humans goes away. And that's what happens in Wall-E, right? People are happy and stupid consumers, know almost nothing about their own civilization and how it works and how to run it. So this is a real concern, and I think we have to find cultural solutions and design the appropriate type of coexistence with powerful machines that I have not yet found. In scouring science fiction, scouring the literature, not finding a vision of how we might want to live a future with these kinds of machines. So to summarize, the standard model of AI is the problem that leads to a loss of human control as AI gets better and better. But I believe we can fix that problem if we rebuild AI on a different foundation, in particular one where the precise objective is unknown to the algorithm and it has to learn more about it by interacting with humans. And I also think this type of AI is just going to be better, right? It's actually the kind of AI that you always wanted. It just wasn't available, and well, it still isn't available. We have a lot more work to do. And so I don't want to say, look, this is ethical, right? And I'm not wagging my finger at the AI community and saying, bad people, right? I don't think that's productive. The only way this is going to work is if everybody in AI understands that this is what we mean by good AI, right? We don't have to tell airplane designers that they should design airplanes that don't fall out of the sky, that don't crash, right? It's just obvious to them that that's what we mean by good airplane design, that it should be safe, right? We haven't got to that stage yet in AI, but we have to, right? The AI community has to understand that good AI is AI that's beneficial to human beings. And so they have to change the foundation on which they do their work. And then I've argued that we haven't yet figured out this question, that if we do have AI of sort of nearly unlimited capabilities, and it's safe, and its whole purpose is to give us the future that we want, that gives us a choice, right? We can finally choose, instead of fighting with each other and struggling with disease and pestilence and famine and so on. We have a choice about what the future should be like, but we really don't know how to make that choice. And we need to start thinking about it. Thank you.
Thanks a lot, Stuart. Great presentation. Lots of, we really need to think about our future. Yes. And I'm just thinking instant reaction. For instance, centuries ago, people were not going to fitness because they had to walk, they had to carry weight, they had to fight. And now we are becoming very lazy, at first physically, and now mentally, as the future that you showed with these people fat and lazy is frightening. Well, so thanks again. I propose now that Anna Cristina will talk about ethics. As you pointed out, it's not exactly the same topic, but of course this is related. And then after we can start the debate. So Anna Cristina, please.
You're on mute. Yeah.
Okay, can you hear me?
Yep.
Yeah, okay. So great talks, Stuart, but let me follow. Thank you, Jean-Pierre, for the invitation. It is an absolute pleasure to be here and to participate in this panel with such distinguished speakers here. I'm really happy, especially to celebrate the 100 years of UFRJ. You know, I got my engineering degree from there, so it's kind of very nice to participate in this celebration. Talking about artificial intelligence and ethics, I think that it's more than necessary for us to design our desirable tomorrow. Let me introduce myself so you can understand where my ideas come from. So I did my PhD at Stanford in artificial intelligence a long time ago, 1992 that I finished. And then I came back to Brazil to become an AI professor. I founded and coordinated an AI lab, and in this lab I could develop many systems for real-life applications in different domains. In the petroleum industry, I have developed solutions, helped to develop solutions that have been deployed and are still in use. So I give this background just to say that I do believe in the AI technology and how it can help society to live better. So I envision a future similar to Stuart, but not exactly that one, the lazy people just drinking and eating, but that we can actually have the technology helping us to live longer and better, to augment human decision-making. So there is like a close connection, human and machines working together. That will allow people to have access to better knowledge of medical, legal, financial expertise, to prevent people to working jobs that might endanger their lives. So I think that this would be a very nice future that I hope I can help to build. On the other hand, artificial intelligence is a disruptive technology. And with any disruptive technology, changes come with a cost. So there is a risk of increasing unemployment and wealth inequalities. In Brazil, unemployment rate right now, for different reasons, it's about 15%. And among young people, this number rises to 30. So we actually should be discussing about measures to counterattack this undesirable effect, like universal basic income, taxing AI, more investment to education, payment for my data. Well, I think these are the big issues that we should be discussing right now. But today I'm going to do more specific issues and more ethical related so we can get along. But I will start talk about the idea that many people have about what is AI. So I do remember a project that my team was hired to develop. It was about developing an AI solution for predicting failures in turbo generator machines. Is this one in the bottom? Turbo generator is a huge piece of equipment to generate energy. So it's a very central piece of equipment for an offshore oil platform. So we thought that was going to be a straightforward machine learning project, similar to many that we had developed for the same company. Later in the project, we realized that there were only few examples of failure. So no data, no machine learning. And we tried to explain to the client, a senior engineer graduated from Federal University, so very good position, said to me, well, I thought that an AI software would be simple. Just plug in your AI software to the equipment and it will eventually learn. I got terrified with that explanation, thinking about all the explosions and shutdowns that would happen till the machine eventually learn what the failure is. But mostly, machine learns from data. Data registers humans' decisions that are context dependent, cultural dependent, time dependent, and many times there are many prejudices inside. So we need to think about what we are teaching the machine. On the other hand, the machines, as Stuart said, have been nudged our decision-making for a long time with the recommendation of products, the information that we should see, and more recently, it's kind of scary, manipulating reality. So this is kind of, it can make us perceive reality, perceive the world in a wrong way. So we should be very worried about that. But today I'm going to talk about our responsibility when we decide what to develop, how to use AI. how we introduce AI in our lives, in the society. And knowing that there is no built-in ethics, no built-in moral values to guide the decision-making of the machine. And then we need to think, and this is the most important issue, what degree of autonomy we are giving to this machine. Recently, I got a project. I was contacted to develop a project to help car transportation company to improve their car client assignment. They run a transportation app similar to Uber. And they told me that they're facing a 48% of cancellation rate of accepted rides. So economic losses for the drivers, for the company, more traffic, more pollution. So I got interested and jumped into the project. So I'm a very curious person. So after look at the usual suspect like distance, car characteristics, traffic, I start asking around me why people cancel the rides after accepting that. And then some people start answering something like that. Well, I canceled the ride because I look at the driver's picture and I found it weird. So I had a bad feeling and I canceled. Nobody could explain to me what weird meant. So I decided to do like facial analysis, looking at different aspects of the facial attributes like eyes, distance, nose, hair, style, and things like that. And then I start wondering, would it be ethical that I developed an AI recommendation system that would improve the match, improve the efficiency of the recommendation, but it would emphasize or consolidate any racial, gender, age prejudice? Is it ethical? The machine has no built-in moral values to decide what is okay or not to learn. So it's our responsibility. Going to ethics, an ethical behavior, is the freedom to choose the appropriate action considering the situation. So if we think about what is appropriate action, you need to consider the options, evaluate the options according to a set of criteria, considering the set of moral values of the society that you belong to. Choose what is the best action and take responsibility of your actions. So it looks like an optimization problem, but it's a little bit more complicated than that, because the evaluating according to moral values is complicated, because there is no right and wrong table. It's a matter of reasoning. Life is always presenting us new scenarios that we need to reason about. So it's very difficult to understand what is right and wrong. And the take responsibility part is also complicated, because it means that you need to understand what the result of your actions, what kind of harm you can cause to you and to others. And this requires a degree of consciousness that is kind of, I don't think that the machine will ever have. And just to have a feeling of what I'm talking about, I'm bringing an example of a 2002 cross-country race. Very interesting example. So in this race, the Kenyan candidate, Abel Multai, he was winning the race by large. After him comes the first candidate, the first runner, that's the Spanish runner, Fernandez Anais. Close to the finishing line, the Kenyan runner misunderstood where the finishing line was and started slowing down 10 meters from the actual finishing line. The Spanish runner, instead of getting the opportunity to surpass the Kenyan, he decided to warn the Kenyan that the finishing line was ahead. So still, you need to run a little bit more. And then the Kenyan could get his deserved victory. Later, a pressman started asking, well, the Fernandez Anais, well, why did you do that? Why didn't you get the opportunity and, get the victory? And the guy said, well, what would I think of myself if I got the prize knowing that I didn't deserve it? So this is the kind of moral values and of notion that no optimization system function can actually register that, because it's always new. And this comes to my last point, the amount of autonomy that we decide to provide to the machine. And I think that autonomy is the big issue here. So to understand what I'm talking about, I'm going to tell a story, or that actually it was, it motivated one of my research looking for type 4 agents. It's very interesting. This story comes from the memoir of General Montgomery, a famous general from the World War II. And in his memoir, he wrote about a German general that had the responsibility of assigning officers to position. So this German general had a very interesting classification method. He classified officers according to two axes: intelligence and diligence. So he would say that, well, counterintuitively, he would say that you should give the highest positions to the lazy, smart agent, because they have the nerve and the temperament for any situation. The intelligent, diligent agent, you should give them high staff position. Keep the stupid, lazy officers with small chores, but very controlled. But you should get rid of the stupid, diligent officers. You are going to lose the war because they are going to do actions with dire consequences. So you should get rid of them. And I am afraid of the type 4 agents. And I'm sure that you have met many type 4 agents in your life. And I brought one example of one of my encounters with a type 4 agent. It happened more or less 10 years ago. I was at that time a professor at UFI, a federal university that is located in the city of Niterói. And I was going to a meeting in Rio de Janeiro, a 45 minutes drive from UFI. So I was almost closing a big project, like a big grant for an AI project, and I was kind of anxious for that meeting. But I got stuck into traffic and I started getting anxious. My meeting could be canceled, and I knew that, people that was going to participate in that meeting had a very tight agenda, so it would mean postponing my project, or even I could lose it. So I was kind of anxious. When I stopped in a red traffic light, I got the opportunity to write a message to one of the executives that I knew it was going to participate in the meeting, and saying that I was sorry, that I was a bit late, but I was going to arrive soon. So when the traffic light turned green, I sent the message and go, and went to the meeting. So when I arrived at the meeting, I noticed that the guy that I sent the message was treating me really rushly. It's kind of very weird. It's not usual for the behavior of that guy. So, but I thought that, well, probably it's because of my delay. And later, when I read the message that I sent, I could understand everything. So the text autocorrection agent was turned on, and the message that I sent was automatically changed to, how is doing the cracker of your son? I don't know how, if it translated well in English, but in Portuguese would be, como vai o jeca do seu filho? This is really rude, personal and rude. And I tried to explain the guy, but I don't think he believed me. But this is how I think, and I'm always afraid of type 4 agents. So while people are afraid of the super duper intelligence, the general purpose intelligence, I'm afraid of giving autonomy to this type 4 agent that will not be able to understand the difference, to see a new detail, to have common sense knowledge, to see the big picture, to have consciousness of the consequence of the actions and what is going to happen. So I want to finish up here saying that I do believe in the AI technology, the power of the AI technology to improve our future. And I don't think that we can stop that. We are going. But I think that AI technology is like a prodigious child that learns fast, but is without the maturity and the ability to understand the moral values of the society, to understand the consequences of their actions, to actually to see what is the appropriate thing to do, and to actually to have the opportunity to reinterpret the problem. So while we are still in charge deciding what to build and what we are going to use AI, I think that we should think through the amount of autonomy we are providing to these smart machines, because we can go to what in the aviation we say, to a point of no return. So we really should think about that. Thank you.
Thank you, Anna, and great talk. I propose that Fabio make the first comments, and then Stuart could comment on Anna's talk, and Anna on Stuart, and everybody could comment. Because Fabio already prepared a few slides for comments about he already visioned all our slides, our presentations. So Fabio, please.
So actually, hi. It's very nice to be here. Thanks for the invitation. I congratulate the organizers and the university for its 100th anniversary. Actually, I think in the interest of time, I will skip my slides because it's very short, and I think we should focus on questions and comments from maybe...
Fabio, just if you skip your slides, I adore your first slide. It says, on the challenge of saying something intelligent about artificial intelligence.
Okay.
It's indeed a challenge for us.
Yeah, because basically it's I think we have had a lot of food for thought. I would only add a few comments, so maybe you want to go for questions, and I will give my comments later.
Okay, so then Stuart, Anna, do you want to comment to others?
I want to ask Stuart about one of his slides, and I don't know if anybody wants to start first, because I was talking, so I would give somebody else the chance. So.
No, please go on.
So my question, I have many questions, but one of my questions related to the machine being able to understand what we humans want, right? And I think we are a very complex group of people. You know, if you think about the Middle East scenario right now, how can I think about an AI software trying to figure out what's the best? Conflicting desires. We have conflicting preferences, and you know, and I had a previous slide. You know, is but with no moral values, and start looking what we are doing. Probably the machine would conclude that the problem of humanity is humans, because we fight, we put people in poverty, we keep our, getting rich and have inequality, unemployment. So I want to ask you if you think that the machine can actually infer what we want for our future as society.
It's a great question. So I don't think there's a collective want. I think there are individual wants that sometimes overlap and sometimes differ. If I had to put my money on one side or the other, I would say that our preferences have a lot more in common than differences. I think commentators and newspapers and politicians like to focus on differences, but in fact, I think we have a lot in common about what we want the future to be like. But that doesn't mean that our actions are all harmonious. And I think one thing to understand is that I'm not proposing that AI systems learn to behave like humans. As you say, humans do a lot of horrible things. And it's actually going to be much easier for the AI to be, shall we say, moral, because the AI has no interests of its own. And I think this is a very important part of the design, right? It has no interest in survival. It has no interest in, electricity or any of those things. Its only purpose is to be of benefit to humans. And if it can do that best by, switching itself off. So if you've seen the movie Interstellar, one of the most impressive scenes in the movie is where the robot essentially commits suicide in order to save the humans. And the humans are really upset about this because they're very emotionally engaged with the robot. But in fact, the robot says, no, this is what I'm designed for. I'm fine, off, bye, and plunges into the black hole. And that's the way it should be. So when you watch a human behave badly, and in the book, I have the example of the passport official who demands bribes from everyone who needs their forms approved or a passport renewed or whatever, right? The official is doing this because the government doesn't pay them very much, and they want to have their children have access to housing and education and so on. So he decides to take bribes from everyone, right? That doesn't mean that the machine is learning to take bribes. What the machine is learning is this person really cares about having a house and education for his children. And then we find, the machine obviously sees that the person's actions are having a negative effect on everybody else. And so we find a solution that doesn't involve bribery, right? And we maybe convince the government to pay proper salary to their passport officials instead. So the question of collective preferences, right? When everyone has a preference about the future, if everyone wants to be ruler of the universe, well, we can't all be ruler of the universe, right? So even if our preferences are all identical, they can still be in conflict. And so, what is the solution to that? Well, this is, as I said, the question that goes back thousands of years. we think of utilitarianism as coming from Bentham and Mill in the 17th and 18th and 19th centuries. But the basic concept that everyone's preferences should be treated equally and you should try to maximize the sum goes back at least to a Chinese philosopher, Bozi, in 500 BC or so. I think Leibniz had some similar ideas. So it's a very natural concept. There are some tricky issues which philosophers have pointed out, and I would say, and I think there was actually a poll, right? If you ask moral philosophers, about 1/3 of them believe in utilitarianism, 1/3 of them believe in deontological approaches, which means that you have to have moral rules specifying what is and is not okay. And then 1/3 of them are virtue theorists, which says that what matters is the virtue of the person making the decision, that you should engage and encourage the creation of virtue. But I think a computer scientist tends to see deontological approaches as a compilation of utilitarian approaches, that we make rules, and this is something that Mill himself said, we make rules to codify the results of long, complicated utilitarian calculations. And we don't continually go back to first principles in the same way that a sailor just uses the almanac. They don't continually go back to do astronomical calculations. They just use the results, which are written down in a book, telling them how to navigate. And I think that's pretty natural. And the virtue part, well, I don't really care if my machine is virtuous. If it kills people for virtuous reasons, that's not very reassuring. I care what effect the machine has on the world. So one way to pose this question, sorry, I'm going on a bit long. One way to pose this question is, what type of machine is it rational for us to deploy? Right? And it seems rational for us to deploy a machine that brings about consequences that we prefer to have brought about. Right? And I think if you think of it that way, you want the machine to be a kind of a pass-through, right? Not bringing in or biasing the preferences of humans. And that way, I think it's another advantage of that approach is it takes the AI researcher out of the equation, right? We are not the people who should be dictating the future, right? We should be enabling the future that the human race wants, but not dictating what future that should be.
Right. Yeah. I'm not sure if I agree with the utilitarian ones, because there is always the risk of I have like that old saying. I have one very healthy patient that comes to my office, and I have 5 patients dying, needing each one piece of my body. So should I kill this healthy patient and save 5? So I'm always afraid of this change.
Right. But if you did that, then of course no one would ever go to a doctor and society would collapse immediately, right? So the utilitarian would say, of course you shouldn't dismember people against their will to save more lives, because that would be catastrophic, not just for that person, but for everybody. Right? And the rule that you shouldn't dismember people is a compilation of that analysis. Right? And that's in fact why we have these rules. Right? Why do we have rules against murder and against theft? It's to allow people to live in security, right? And it's to give people that sense that they can live their lives without constant fear of attack. Yeah. And so these are not inconsistent. They're really just two sides of the same form of reasoning.
Yeah, but this size that you're talking about is kind of, it was like a way of that how we could, is as if we could map the future, the possible scenarios. And ethics would be like, you should be able, so you and the machine, and this is my whole question, is not able to know how to react in a scenario that was not, designed to act. So, but many people are raising their hands to ask you.
Yes.
Sorry.
Yes, and well, that's a great start. Thanks to Stuart and to Anna. Priscila is asking for a question, so please, Priscila, and then.
I have many questions, but I know I don't have time for that. So I ask
one question.
One question. I would ask two.
One at a time. One at a time.
To Stuart and maybe to Ana Cristina as well. What do we do while the machine doesn't adapt completely to the perception of being provably beneficial to humans? Should we just deploy the machine when we can have this ideal machine that we know is going to be beneficial, or we think we know? Who is this we? And you said that optimization, and this was an area together with control that was exogenous, but you talked about optimizing, Stuart. So my question is, how do you reconcile this not exogenous optimization with this optimization you mentioned?
Okay, so I think there were two questions there. So one was, what do we do before we have these provably beneficial AI? So I think that there's sort of two ways to take the question, right? I mean, you're right, we don't yet, I mean, we have very simple examples. We have algorithms, we can solve very small instances of the assistance game, and we can actually look at the behavior, and it's often very surprising what the machine half of the game actually does. And it's also interesting to see what the human, right? We don't have an actual human, but we imagine one entity that has the preferences, and the other one is trying to help the first entity, and in the process learning more about what the preferences are. And the human half is motivated to teach the machine half about its preferences, so that it can be more helpful. And we had a little grid world where there were some good parts that gave reward, and there were some bad parts that were dangerous and gave very negative reward. And when you solve the game, what the human does in this game is actually take the robot and show them the bad parts and then walk away from them, right? Not actually go into the hole, but go right up to the edge of the hole and then walk away. And then the robot learns that don't go in there, right? Because the human, otherwise, why would the human do that, right? And so the human has these teaching behaviors, and the machine actually, because it's also solving the same game, is able to understand what the teaching behavior means and to learn about human preferences as a result. So almost inevitably, the machines are always going to be radically uncertain about human preferences. I mean, not least because we're also radically uncertain about our own preferences. Until you get to compare two concrete futures, there are many things you don't think about. For example, if I change the sky to yellow with purple spots, is that good? Well, I don't know. I haven't thought about it, right? No one's thought about that because no one's been in the business of changing the color of the sky until recently, when it turned orange in California. So when you have machines that are very, very uncertain about human preferences, how should they behave? Well, the way they should behave is to be very cautious and not change the parts of the world that they don't understand, right? So you get this kind of minimally invasive behavior, if you like, which is exactly what you want, right? And so if we deploy these agents, initially they're going to be extremely cautious, right? They will, they'll save babies from being run over by a bus, and maybe they'll bring you coffee in the morning, but they're not making a lot of morally ambiguous decisions because they don't understand human preferences well enough. But we have a lot of work to do to bring this type of technology to a level where the big companies of the world will agree to deploy it for their tasks.
before I take my privilege of extra power to ask a question to Stuart. Actually, you said that I just simplify. What is important is the action. That is, as long, for instance, as the robot will not kill a human being. But actually, there's this dual view of inside the black box, that is the rationale, which is important for explainability, for instance, not for instance, actually it's very important, and also the actual observed action. So I will take, to get to my point, I will use a Buddhist, a Zen Buddhist, because of course, Koan and Zen, there are a lot of interesting dilemma, and so the idea is the scenario is as it goes. So there's a samurai who's there's a country where there's a king who's very, very bad, very, very cruel, very bad against all his people, and there's a samurai, so it could be in Japan, who decides to kill this very awful king. Why? Because he wants to save for he's compassionate about the people of the country, right? And so he's ready to go to the extreme, that is to kill. Although he's Buddhist, he doesn't want to kill. And he searches for the king, and he confronts. He gets to him, and then he's ready to, with his sword, to kill him, and then the king, so cruel, etc., but turns to be very to liquefy and to be very coward, and so he has a shame of this king, and then he hesitates to kill him, to kill the king, because he feels that his noble intention to kill the king for noble intention, for compassionate for the people of the country, will be polluted by a bad emotion, which is being angry about the behavior of the emotion of the king. And then, seeing that, the king spits at the face of the samurai, and the samurai stops even further because he doesn't want his emotion, his rave, to get. And then he decides to get out. And the story stops here, so we don't know if after he gets his temper back and he goes back or not to kill. So the point is, okay, of course we wouldn't like the machines to kill the people, and in the case of some new Hitler, etc., this could be debated. But my important point is the difference between, again, the observed action and the rationale that is for doing the action, which could be based on some virtues, but which could lead to some maybe deontologically not. So how do you see this kind of conflict between internal virtue and, in a way, external norms?
Well, let me put it this way. If suppose I have two machines, and one of them does something bad, but has virtuous reasoning, the other one does something good without any virtuous reasoning, maybe just a big lookup table, right? Would you console the mother of the child that was killed by the robot that did the bad thing by saying, oh, don't worry, it used virtuous reasoning while it was killing your child? Of course not. It has no moral value whatsoever, right? Which lines of C++ were executed when the machine was doing a bad thing, I don't care.
Yeah.
Right? It has no moral value. So I don't believe that virtue theory has much to say in this regard. I don't disagree that when we're talking about humans, it does have moral value that people be thinking in ways that are virtuous. but I don't attach any moral value to which lines of C++ get executed.
Yeah, this is exactly why I agree. There is no built-in moral values ever, in the machines. I don't think that's ever possible. Maybe we disagree with that, but this is why I think that human must be in control.
Thank you for.
Alan has had his hand up for a while.
Yes, Alan, please.
Yes. Hi, good afternoon. And first of all, thank you for the organization for this wonderful panel. I work with copyright, so I've been involved very recently with AI systems and following them much more as a student than actually research on it. But I have I want to take the discussion to just bring a different thing to the discussion. Art, usually the production of art and the enjoyment of art, is something that we always being very, we always give it a different level of perception. We perceive art as bringing us to a different sensibilities. So something that would be very human in a way, that's very distinctively human, this enjoyment. But now we see quite a few AI systems producing a lot of what would be this sensitive objects that would convey cultural meanings and everything else, like books, paintings, and you name it. There are plenty of them. Music, lots of them, and so on and on and on. And that brings a different question, which is, would we need, or do we need already, or will we need to start labeling AI or whatever name we will give, made things and human-made things, as we do now, as, for example, organic produced or mass-produced and so on. Has the time come for that already? And this is the first question. The second question, would we attribute copyright to these works? Just the follow-up questions. These works that our AI system made, should we attribute them copyright, which means author rights, which is something that we still describe as something that sort of transcends humanities or transcends our day-to-day life. So that's it. Thank you.
Thanks, Alan. So actually, your first question will be, it's exactly for the second panel. The second panel will be exactly about that. So I propose that François and other panelists will answer, not now, but defer that. And your second question about copyright, talvez, and authorship rights, creation, who's in charge? Who's the author actually of the creation? The machine, the combination of the machine and the human being, the artist, the artist, the implementer of the system, etc. This is also a very good question. But this, again, is for the second panel. And just some announcement. Tomorrow there will be another panel which will be dedicated exactly about AI and law, actually. This will be organized by Mackenzie University. Will be from 6:30 on the YouTube channel of Mackenzie, and I will participate and talk exactly about that. So please, I propose to defer your question very soon. Okay, Alan, thank you for your. And do you? I think Priscila had another question, and I don't know if François or Fabio want to jump into and to ask a question. And there are also some questions from the public that I will also show. So if nobody...
It is more a provocation, because Stuart mentioned minimize. When you minimize, you are dealing with optimization embedded in your algorithm already. So although you do not accept exogenous control goals or optimization, but you are already embedding some of these mechanisms at least while you don't learn completely all the preferences of the humans.
Yeah, in a sense, right. We would like, I mean, if humans have a preference, they prefer future A to future B, then we want the machine to help bring about future A rather than future B. So in that sense, yeah, the approach is based on optimization because it's based on trying to reflect human preferences. But the key difference is that the algorithm does not have a fixed known specification of what the preference function is, right? So there is a built-in assumption that the human beings have preferences about the future, and that assumption can be questioned in two ways, right? One is that, you know, probably our minds are composed of multiple conflicting subsystems that sort of take control at different times. And so it's not clear that we have a unique, stable set of preferences about the future. The second point is that our preferences are malleable. They change by experience. So we might want something to be the case tomorrow, but when we get to tomorrow, we actually want it to be different from what we wanted yesterday. And that's been a philosophical puzzle for a long time, right? Because now you've got kind of two people. Which one are you working for, right? Are you working for me today or are you working for me tomorrow? I don't think we have a good philosophical resolution of that question. So I don't see any conflict in the view that we can be trying to produce the best result, but not know what we mean by best.
Great. So thank you, Stuart. So maybe we can. I propose to go to the question from the floor, from the audience. So, for instance, there is. I'm trying to find it again because there's so many. Sorry, just going to put my glasses also. It's about it's a question about violence against machine. Trying to find it. Couldn't find it. What happened? Sorry. But anyway, I remember. I cannot see more anymore. Yes. So it's in Portuguese, but I translate instantly. So how do you evaluate the people who make harm, actually destroy machines, intentional meant? It would be because of ethics in a way, in a different way, to protect the machines. That's
yeah. I don't feel protective towards machines, and you know, it's the same as destroying a car or, you know, breaking a window. I mean, these are just inanimate objects. But I think the difficult part is going to be that we will start to form emotional attachments to machines. Probably some people already do. And the more we anthropomorphize the machine, then we give it a human appearance, we give it a human voice. This creates a moral illusion that the entity has some intrinsic moral value of its own and some right to exist, and so on. And that illusion, I think, is pretty dangerous. So like Turing, I would argue that we should avoid creating machines that have these human characteristics, because it's a form of lying. It's a form of lying that takes advantage of our built-in psychological structures that we can't help but respond to the human form and the human voice. And using that to deceive people is bad in itself, and I think it also creates this illusion that the entity has moral rights to exist. It's much easier to switch off, a squat gray box than it is to switch off something that looks like a child. As you see in AI, the movie with the 7-year-old boy robot, that's very difficult for the mother to abandon him in the forest.
Oh, let me jump to this question, because I think I agree with Stuart. It's a machine. So, and I also agree that I think that one mistake is that we want to create artificial intelligence with an embodiment of a human being, and this makes these mistakes, mislead our mind of what we're talking about. But there are some people that probably don't think like us. So in Dubai, there is a humanoid called Sophia that it was developed in Hong Kong by a software company, and it got the Saudi Arabian citizenship. So it's going towards creating like some rights for this machine. If they have rights, so I don't know what are they, but we need to follow the rules. And so on the other side, when you destroy the machine, you have to pay something for the owner of the machine, because right now the machines have owners. It's like a car. And last but not least, this is a wonderful opportunity for us to understand what is the society's problem with the machines, or with the gender of the machine, or with the age of the machine, because they are society. People are expressing themselves, and it might be a good data to understand what is going on. Maybe people are, are suffering from unemployment or whatever. So I see more like an opportunity to understand what is going on, accepting this new technology.
Maybe I take another question from the floor, and I propose to close this first block, because it's already 9 p.m. But because of course there's a lot of things to say yet to go for second block. So the question is about some topic which is a hot topic. I read it, it's in English. The advance of AI in the contemporary world is very important. A question that has emerged is how algorithms are exercising power without control in society. So it's exactly the topic that Stuart addressed. An important example is the lethal autonomous weapons. What do you think about the power of algorithms and how to create a political order based on the interaction between humans and machines? So, Stuart, I guess.
That's several questions. I'll focus on the lethal autonomous weapons because that's a very concrete question. I think they're a terrible idea. So just to be clear, what does it mean? It means a weapon that can locate, select, and attack human targets. And because it can do all those things, and just to be clear, you can buy these weapons now. Go to Google or any search engine, type in STM, which is the manufacturer, Kargu, K-A-R-G-U, and you will see a weapon that's advertised as being able to do autonomous hits on humans by human figure tracking, by face recognition, and so on. So you can buy these weapons now. And because it can do those three things, that means that there's no human supervision required for it to carry out an attack. And that means that you can launch 10 million of them against a large city, and they will find and kill all the people in the city. So you're creating a weapon of mass destruction that's much cheaper than nuclear weapons, that's much lower tech, if you like, doesn't require the huge industrial complex to create, and that's easy to proliferate, and also doesn't leave a huge radioactive contaminated smoking crater behind. You get to preserve all the property and assets. So you're creating a weapon of mass destruction that is in pretty much every aspect worse than nuclear weapons in terms of effect on human life and advantages for the person using it. If anyone thinks this is a good idea, then go ahead. I have yet to hear anyone give a justification, but all the major nations in the world are plunging ahead as fast as they can with an arms race to create these weapons.
Thank you, Stuart. So I propose to close and this first block, just saying two little things. Actually, not a question, but on a comment by Martin in the question, who says, very rich panel, thank you. More questions than answers in relation to ethics and AI. And I think this is true, of course, but because there's no definite answer, and we need all to, that's my personal viewpoint, to all of us, and not only specialists in AI, to think about it. Because in a way, like if I paraphrase some French colleague, specialist in ethics, who's Laurence de Villiers, said, I heard her saying that ethics is not just about technique, it's also about social power. So it involves not just again technician and scientist, but we need to think about it globally, and this panel is a way to try to in a pedagogical way for people who are not specialists to understand a little bit the deep questions that we are facing. Anyway, well, you can comment on my comments, Stuart, if you agree.
I think we should move on to the next
yes.
Part of the panel. I think this has been a great discussion. Thank you.
I completely agree. And I would like to thank all Stuart and Anna, Cristina in the first place for the great presentation and all the discussion. So now I will share my screen again and present the second block, which is can a machine be creative? That's one of the questions, and we'll see that actually François will not answer to this question because I know already what. I just take some fun cannula hoax to start. That we could again. I already made in my presentation some relation between machines and animals. And in 1910, there were some funny French painters who put a pencil attached to the tail of a donkey and made a painting. The painting is on the right side, and they named it. Not was the donkey. Donkey was named Lolo. And the human beings, owner of the donkey and the artist, named it Et le soleil s'endormit sur l'Adriatique, and the sun went down on the Adriatic Sea. So actually, we will hear about François, but he personally, I agree with François that more interesting is to see not the potential for creativity of a machine alone, a bit like in a way less dangerous like autonomous weapon, but for the co-creation that is between a human artist and a machine. But let's go to François. I stop my sharing. And François, please, this is up to you.
Yes, hello. I'll try to share the slides. That's the most difficult part. Sorry.
It's some personal assistant to use Zoom.
Sorry. Yes, I'm almost there. Share.
You're
Yes.
there.
Oh no, sorry, no, not share. Present. Sorry. Is it working?
Yes.
Yeah. Hello. Thanks a lot, Jean-Pierre and everyone for organizing this. The first thing I want to say is that I'm really not at ease at all about talking about the future. Predicting the future and predicting what's going to happen with AI and all this. I have the impression that most, if not all, prediction usually fail, and then we humans have an incapacity to predict, unexpected things, which will, I'm sure, happen, but we have no idea which ones and how. So all these questions that have been raised before by Stuart in particular also apply, of course, to the domain of creativity. I would like to just mention that in the last, I don't know, maybe last 10 years, 6 years or so, there were a lot of applications of AI. So in fact, it's not really AI, it's mostly machine learning and mostly deep learning, not only, but mostly, have been applied to domains that are well-defined. And so what I mean by well-defined is domains in which there exists a function in the mathematical sense that tells whether an object that we want to create is good or bad, or is desirable or not, or is satisfying or not. That's the famous loss function, for instance. So Stuart gave the example of autonomous driving as, and he made a kind of a case to say that this was actually very hard to define a function, but in some sense, I would like to challenge that and say that, yeah, maybe it's not very well defined, but it's still quite well defined. So basically that you want the car to go from A to B, you want the car to follow the rules, you want the car to minimize the number of people that it kills per second, or that kind of stuff. And I agree that it may be not so easy to do, but still you can do something. When you do face recognition, you have a well-defined problem. When you do tumor detection, all the problems that we are talking about when we talk about AI, they are quite well defined, and this, of course, is debatable. Now I'm talking about creative domains, and actually I should be more talking about artistic domains. And what is art? Oh my God, I don't want to enter this discussion, but I can give a very simple definition of art. Art is about creating objects for which there does not exist any evaluation function. So for instance, if you talk about music, no one knows what is good music or bad music. If you talk about pictures, it's the same. If you talk about a book, what is a good book, a bad book? It's really hard. I mean, it's not hard. It's we kind of know that there is no such function out there. It's hopeless. Yet many people have used all the techniques of AI to actually address these things, to create artifacts, artistic artifacts. So there were a number of spectacular things which were obtained in the last years, and you have all heard of painting in the style of Rembrandt, which is original, but yet in the style of, and I mentioned in this slide a couple of other things in the domain of script writing with deep networks, images, even recipes, automated cooking, and all these things. So all these things use AI to create artistic artifacts, and with some success, I would say. And so here I would like to talk more precisely what I have been interested in which is music. So in music, of course, it's exactly the same. Many people have used AI to generate music, to make music under different forms. I just refer to this book by Arthur Miller, who is not the husband of Marilyn Monroe, but is another one, which is a very interesting book, which tries to gather all the viewpoints about that, about what it means to use AI for generating music. So before continuing, I want to make a pause here, because there is, if you read the press about, lots of press about AI and music, AI and arts, of course, but also AI and music, and the questions are kind of always quite similar to the questions which have been raised before, just before in this panel, about is AI going to take control? Is the AI going to replace artists? Is AI and all that? And so I have to say something, maybe it's a bit provocative, but that's for the sake of lighting up the panel, have discussions. I don't know any researcher in this domain who thinks that AI is going to replace artists. I mean, I've never met anyone like this in my life. I have read a lot of papers, actually most papers talk about that, but frankly, this is a non-existing subject, basically. So what's at stake here is how can we use all these techniques to do interesting stuff, right? It's not at all about replacing anyone. Actually, it's probably even the opposite. So I try to make the case for that in this very small introduction. So the background I have is well, I've done a number of things, but here I would like to talk about an artist whose name is Skygge, which means shadow in Swedish. And this artist has used all the technologies that we have developed in the last 10 years or so to make music, and he made an album called Hello World, which you can hear on all the platforms, which is the first pop music album, which was composed, also arranged and produced using various kinds of AI. That's the first time that AI was used for pop music, and it's important because pop music is a very particular kind of music. Usually it was really mostly about classical music that AI was applied to. And I just want to mention a more recent, Hello World was in 2018, 3 years ago, and last year another album called American Folk Songs. I just want to mention this because it's a very interesting achievement. It's a blues album in which there are songs which are sung by Pete Seeger. So Pete Seeger is a very famous blues singer in the States. Is dead now, of course. But what Skygge did is he got the voice of Pete Seeger, the a cappella voice, just the voice, and then he recreated string arrangements on those traditional folk songs, and the arrangements were generated with the AI that we do at Spotify, and that's very, very nice, as you can see by some critics. And I of course encourage you to listen to this, and it's not to get more money because I will have a couple of streams. As you know, this will not change my revenues a lot, and Skygge's as well. So I just skip this. I don't have time to play a lot of videos here. So the provocative things I want to say again is that all these questions is a computer an artist? Is AI, can AI be autonomous? We have talked about that just before, but in the case of music and art, you know, what does it, could an AI be completely autonomous, like decide to compose a song in that style, with that meaning, intention, all that? So that's the question that people talk about. What about agency? So agency is the word that means, you know, giving an AI a sense of agency, meaning like the people would have the impression that this AI is actually human, you know, as an agency, like a human being. Does it have intentions? Does it know how to give a sense of direction in the work that it produces, and all that? So again, I can just repeat that all these questions are debated in the press, in the media, but not at all in the research community. I don't know any researchers taking these things seriously. I've never met one, actually. Maybe there are, but and so that's a way to say, hey guys, I'm not going to answer those questions because I don't think they are very interesting. And I think there are other questions which are actually very interesting, which deserve more attention. So this artist versus tool is a media thing. I mean, it's obviously AI is going to be used and is already used as a tool. That's kind of obvious. The thing that occurs now is that, you know, in the last year there were, like, we could say, proofs of concept. So we did this album Hello World, but there are other people did other things. So it has been shown, I think, quite convincingly that AI, again, I'm very general here, but machine learning, let's say, can be used to help people produce really interesting music in many different genres, in many different contexts. So the proof of concept has been done in some sense. So the next step now that we have to address is to go from this proof of concept to the actual goal of developing tools. And that's actually very, very hard. And it's very hard. It's not hard only because of engineering issues, which are always solved more or less quickly. It's hard for more fundamental reasons that I would like to stress here. And as Jean-Pierre said, I'm now working for Spotify, and one of the goals of Spotify, of the mission, is to give 1 million artists the opportunity to live up their work, which is quite a big challenge if you think about it. I will just give you a figure which I got recently about artists and music. In one day, you have today. In one day, we create as many new music titles as we did in 1 year in the UK 20 years ago. In one day. So it means that the number of artists has exploded, and of course, and the number of music, the number of music titles has, of course, exploded as well. So there is a huge number of artists now today, and the challenge is how can we create a system in which they can actually live off their work. You know, that's a big challenge, and as you know, there are lots of controversies about that, which I will not enter into now. So I just want to say, I'm not going to answer now the question, is AI going to be an artist? Of course, I'm happy to talk about that after this, but I just wanted to point out 4 questions that we think that are relevant and interesting, based on the experience that we have now at trying to build AI tools for artists, right? So the questions are the following. I will just mention them, and then maybe, depending on the time, just spend a couple of seconds on each of them. So the first thing is, do better models generate better artifacts? So basically, if you have a better model, so now you have a AI model, every day you have papers about new architecture, new forms of neural networks, of deep learning architecture, or whatever. You had deep networks and GANs, then VAEs, then blah blah blah. So every day you have a new models, and they're all always better than the one that you had the month or the year before. The problem is, and they are better in concrete ways. You can measure how better they are, because they just learn better. They learn more, they learn faster, and you can measure that. But the problem is, if you have a better model, does it mean that you're going to generate something that's more interesting? I'm talking here about artistic artifacts, right? That's a question. I'm not saying it's not the case. I'm not saying it's the case. I'm saying it's a big question. And I will try to give some examples. The second problem is popularity. So the only thing we can measure when we talk about artistic artifact, and Stuart Russell actually talked about preference in his talk also. so we can measure preference. We can measure what we call popularity. That is basically how many times a given object is chosen or bought, or if it's music, how many times people stream, you know. So we can measure very easily popularity, and it's actually very easy to measure today. But we know that popularity is not significant. So there is no clear relation between the popularity of an item, let's say a music title, a painting, a countryside, a shoe, a car. So there is no clear relation between the popularity and its actual value, or its intrinsic value, as we say. You know, it's not clear. It's definitely not clear. And actually, there are papers showing that it's not only not clear, but it's clearly chaotic. The third idea is that listener, or if you want consumers, people who are going to receive these artistic artifacts, they are not rational agents. So Stuart again said something actually I think is very true, that we don't know about, you know, the machine doesn't know really about preferences. But the problem that these preferences are not preferences. They are not even, of course, they are more than unstable. They are much more hard to understand, and actually we don't know much about that. I will give a few arguments about that. And the fourth question is that the people who create music themselves, they are not rational. They do very strange things. We have a very strange relation, we humans, with what we create. It's not like there is a human being H and he creates an artifact A. It's more complex. There is a problem of appropriation. There is a lot of things going on between a creator and what he's doing that we understand very badly, and and I think I argue that we actually understand that it's really very complex. So there are all these questions which are at stake, which we have to address in order to actually go from the proof of concept, let's say, to the actual, let's say, industrial tool here. So the first thing, I will go very quickly, and Jean-Pierre, please stop me when I'm too long.
No, please take your time. Take your time.
The first thing is, you know, better models, better artifacts. So I just give an example here. So in 1956, and that was really the beginning of computer science, there was something called the Iliac suite. I don't know how you pronounce suite in English, but la suite Iliac. So it's a series of musical pieces which were composed with Markov chains, and at that time in '56, it was quite something to do that. And there is a photo where you can see Hiller and his axon, and they are big. They have machines filling up a whole university to do this. And you can listen to this. I can send you the slides after. You can listen to this on YouTube. It's still there are YouTube. There are versions of these music compositions played by humans, which are on YouTube that you can listen to. So in 2016, which is how many years? 60 years later. No, 70 years later. And Jean-Pierre mentioned this. Deep Bach is a system that uses deep learning to learn how to generate Bach chorales. By the way, the Iliac suite was also supposed to be in the style of Bach chorales as well. So it would create also 4 voices of things in the style of Bach, more or less. And obviously, there is a huge difference between the recurrent neural networks architecture of Deep Bach and a Markov chain. I mean, it's obvious, we know very well it's much better in all possible ways. And this was Deep Bach generates a Bach, and you can listen to this also on YouTube if you want. And there are renderings also played by humans. The one I have in my link is played by a flutist. And I asked the question, which one is the most interesting to listen to? So that's a very strange, complex question, actually. So if you are interested in technology, Deep Bach is more impressive today, of course. What will happen in 20 years? I have no idea. I don't know. But if you're like a musician, you know, there is something, a kind of a paradox. It's obviously deep Bach is much closer to Bach, and to the point that, as Jean-Pierre said, that you can even fool some people into believing that it's actually Bach. But it's a bit on the boring side, right? So when you learn how to write a chorale in the conservatory, first of all, it takes a lot of time. It takes like 7 years or even more. But it's an exercise. Come on, it's an exercise. It's an exercise that's really hard to learn. But in the end, you don't play these things. You just try to get a good grade, right? But if you listen to the Iliac Suite, it's still interesting. It's quite intriguing, you know. So there is no mistake. It's just a bit strange. So it has this kind of appealing nature of being not wrong and being a bit intriguing and not completely understanding what it's about, which makes it, I think, and that's my personal opinion, it's actually more interesting to listen to. The second question you could ask is, how much are you willing to pay to listen to each of these things? And I would not be surprised that the Iliac Suite would win for many reasons. It's a question. I'm not saying it's true. It's a question. I think everyone should try to have his own opinion on that. So better model, I think, do not necessarily imply that you have more interesting or better music. The second point I wanted to make is about popularity. What we can measure is popularity. And when you use machine learning and you talk about music or you talk about artistic artifact, that's the first thing that you think about. Okay. Let's try to build a system that learns how to write a song based on the popularity of the millions of songs. So we have now today on the streaming platforms about 50 to 60 million songs. So we have plenty of data to use, right? The problem is that popularity has been shown, and I here quote a paper by Salganik and Watts from Science that's very interesting, in which they showed very convincingly that if you take two groups of people, so that's a very brief summary of what they've shown, that you take people who listen to music and rank them like in complete isolation, and you take another group who listens to the same music, but they are exposed to each other's preferences. There is what they call a kind of social pressure. Basically, what people prefer is going to be translated in a ranking of what you are exposed to. So if you compare the groups, then you have completely incredible results that basically, when you have social pressure, the hits, the titles which become hits are completely unpredictable. So if you do the same experiments 8 times, which they did, you have different results, whereas you don't have that in the non-social pressure case. So what this shows is that very clearly, when you have a social pressure, you have a chaotic data. So the popularity data is not reliable. It does not correlate well, actually very poorly, to intrinsic values. And that's very, very clear in this experiment. It's very general. It's not for music, it's for any cultural market. So when we measure popularity, basically we are wrong right away. So we just try to model chaotic stuff. That's a very interesting paper, which I think is very intriguing, and also cast doubts about the very idea of using machine learning for that kind of stuff. Third point, which I label listener is not a rational agent. So I just want to mention some studies that we have done here at Spotify, where we have been interested in how people listen to music. Again, preferences. People usually when you talk about music to people, they say, oh, I like this. I like Ed Sheeran. I like the Beatles. I like this song. I like that song. But that's a very macro level statement. Now with the streaming thing, as you know, young people, they listen to music on smartphones, and because there are so many titles, then they skip a lot, right? So they have a playlist, and then they listen to a few seconds and then they say, oh, I want the next one, I want the next one. So that's what we call skips. And so we have been studying skips, which is, let's say, a micro level, view on how people actually listen to music. And there are a number of studies saying, first studies that that was made not by us, but that to say that the most skip profiles look more or less the same. That is, many people, most people skip at the very beginning, so they don't have any patience. They don't want to wait, and so all the skip profiles have very high skip at the beginning, and then kind of phase out. But then, if you look at more in detail, which we have done, we have found very interesting stuff. Basically, so there is a paper here which I quote, but basically what we have found is that the skip profiles, which is completely unexpected, they don't depend on time. So if you take a given song and you look at the profile and you look at the profile 1 week later or 1 month later or even 1 year later, the skip profile is going to be the same more or less for a given song. And it's also going to be the same not only in time but also in space. So if you look at the skip profile in Europe and the skip profile in the States, for a given song, they're actually the same. They look exactly the same. So they have bumps, as you can see more or less here, and the bumps are exactly the same positions in time. And that's very intriguing, because when you think about music and preference, you would think that, oh, all people react actually very differently to a song. For instance, I love the Beatles, and maybe Jean-Pierre does not like the Beatles. We are going to skip very differently there. But in average, statistically, it's not true. And the skip profile is actually a kind of DNA of the song. So the next study we did is trying to understand, what make people skip? Why do people stop listening to a song? In other words, when do you get bored when you listen to a piece of music? And so we have tried to understand this more fine grain. There is also a paper I quote here. And basically, the thing that we find is that people skip when something happens in the song. So, for instance, the drum starts, or the voice starts singing, or the voice stops singing, or the guitar starts. So it's always when there is a musical event starting or finishing, then there is a bump in the skips. And that's very intriguing, because and that leads to a paradox, which is the following. So if you want a song where no one skips, or with very little skips, the best is to do a song in which nothing happens. Basically a drone sound or texture that goes like, or like an ambient music. So you will have very little skips. That's great. The problem is that no one is going to listen to this, because it's too boring. So in the end, a song that works is a song where you have lots of skips, which is paradoxical, because skips equal people stopping listening to this. So we still don't really understand the dynamics between popularity and a skipping profile, but definitely there is something there that we don't understand at all. I mean, there's lots of things to learn from this to try to understand really what it means. The last thing I want to mention, and I stop on this, is that the artist is not a rational agent. It sounds a bit trivial, but it's actually not. So what I want to say here is that we have discovered that there is something called the IKEA effect. So IKEA is a Swedish company selling furniture that you buy and then you do it yourself at home. It takes hours usually, or days. But there is an effect that has been discovered and studied by psychologists, which is that they call it a cognitive bias. Basically, when a consumer places more value or disproportionately high value on products that they partially create, and it's a very strong effect, which has been shown in many different areas. For instance, if you sell your house, and if you have built the roof yourself, you will tend to sell it at a much higher price than the market price, just because you think that it has more value, just because you did it yourself, right? And this has been shown really in many contexts. It's a bias that we have. which is quite massive, I would say. And the thing is that, so we have been working with and playing with lots of AI tools to make music. And again, it relates to the problem that better models do they make better music? So in the end, what we have kind of observed is that if you have a great algorithm that creates a very, very good, let's say in some sense, piece of music, then you will have an appropriation problem. Basically, because the user has just clicked on the button, he will think that this thing is not his thing. So he will not be interested. And he will, for instance, he will not consider that he is the creator of this thing. So we have to study the IKEA effect. And so we are working now on the protocols trying to show that if you do the same artifact, but on one click, or if it requires more work, then you will tend to think it's better. Or you will tend to think that it's more your thing. And then consequently think it's better, you know. So because you just want to feel that it's your thing. And so this is also something that we don't understand very well. And so it means that what we look for is maybe not necessarily the best algorithms, but the algorithms which lead to more appropriation by the user. And this is also quite not very well defined, but it's definitely what we want, because we don't want one-click button systems in which can you imagine that would be actually a paradox if you had a system where you just click on the button and you have a hit. I mean, first of all, you could create millions of hits, which is not possible because you can only have a limited number of hits, and then these hits obviously would not have a lot of value because no one would have would sense that, would feel that it's their thing. So so this is an interesting subject I just wanted to mention here, that prevent us so for the moment to go really into the tool and the industrialization of the tools. So the conclusion of this is, it's not the time to worry about AI replacing artists. I think it's one of the deep learning guys, I think it was Benjo, I'm not sure, said that worrying about these things is a bit like worrying about overpopulation on Mars. So of course you can be worried about that, but it's probably not the right time. Let's first try to get there, and then we'll see. So, but conversely, there are many very interesting questions that this AI thing actually raising, which are really fascinating and very, very challenging. And so we don't need to go to that step of worrying about the future. There are already very interesting problems to address and to solve, already addressed. So what we need now is just more people using AI prototypes to find the right design for tools. And this is not a marketing problem. This is not engineering problem. Not only, it's really a fundamental problem. How do we put the power of give to the creators the power of all these incredible algorithms, so that they produce more interesting stuff, you know? That's really what the users want, that's what the creator wants, that's what the researchers want. That's not what the media want to talk about, but that's really what's going on. And so I just wanted to propose these 4 points for this workshop. But of course, I'm happy to talk and argue about the more general issue of AI versus artists, as you want. Thanks a lot.
Thanks a lot, François. Thanks. Yes, please exit. Yes, great. Wow. Great talk, as all talks. Just one little organizational point is that, as you know, time flies. So it's already almost 10 to 9. So we decided, no, François, don't worry. We decided to skip the third block because because it's no point. It's better to leave time for respiration and discussion. So actually, François, you could try to see if exactly this skipping the third block it's part of the DNA of this panel. But we need to do many many panels, many people listening to corroborate this. So now let's go back to debate. So please, within the panelists, who's going to ask? I saw that Priscila and also Fabio. Fabio, you haven't talked yet, so please, Fabio, please feel free to ask question.
Right. Well, in the interest of time, I'll try to be very brief. I know we don't have much time, and this is an endless discussion. We could go on and on. I would try to connect both sides of the debate. I'll try to connect the first part, which was about risks, the risks of AI, and the second part, which is about this art and creativity. I think these two points of discussion, they require different AIs in a sense. So if I were to think about ethical AI or decision-making sensible AI, I would go for what I would call neat AI. And I'm going back to a debate that exists in AI for decades, which is the difference between neat AI and scruffy AI. This goes back a long time. So the neat AI is the AI that is based on mathematical analysis principles, and it's supposed to start from first principles and reach intelligent behavior. Scruffy AI is like the AI that you get from neural networks. You try a lot of things, you try data, you get data, and you produce patterns, and you learn from patterns, and you see what happens. If it works, fine. And I think if I were to bet, I would say that ethical AI and the kind of AI that Stuart Russell was talking about, the AI that is based on loss functions that take into account human being behavior and preferences, I would think that these AI, the AI that addresses the risks that we saw in the first part, calls for a neat AI kind of thing, because you need principles, you need mathematical analysis, you need to prove things. And the creativity stuff that happens today is really scruffy. It's really basically taking a lot of data. You learn lots of models that nobody knows how to interpret very well, and you get music out of them. You get images. You get fake news. You get fake images. You get fake bath. You get fake music. So I think one thing that has to happen is a more integrated kind of AI, where you have neat AI giving you the principles in a way, in some way, and scruffy AI getting you the patterns from the data. So I guess the question I would try to articulate to François, if I may try to be a little, try something different. Would you think like, is scruffy AI, like getting data, lots of data, is the way to get into artistic behavior? Or do we need principles into this process to regulate and avoid unethical pieces of decision making?
Yeah, so I'm. Thanks for the question. I'm not sure I'm the right person here to because when you talk about artistic stuff, I mean everything is okay. We are not talking about weapons, killing people, or taking, just talking about creating stuff. The worst that can happen is that people create things which are not interesting, and that's all right. That's not a big deal, right? It's just a waste of time. In some sense, it's really strange because I don't think we can compare what's going on in the artistic world with what's going on in the more serious world of cars, health, wars, and all these things. So in the artistic world, the more strange. I mean, everything is permitted, right? There is no problem in trying to do anything you want. It's completely free. And I think that we are still in very strong need of people experimenting and doing all sorts of crazy stuff. For instance, I take another example. So I don't think I can really answer a question, but I take the example of the bias, So many people say that there is a problem of bias in machine learning because the data is biased. So if you try to learn about the concept and the data you use as biased, and then at the end you learn with bias and all that. So there are lots of works on trying to avoid bias in machine learning. But in music, bias is very good. I mean, we want bias because you don't know when you learn about, you don't know, I'm a musician, I want to have a system that helps me compose, and I want the system to be biased, of course, obviously. For instance, I want to be biased in a given composer, or even myself, or a series of, so if it's not biased, it's not going to be interesting, you see, because it's going to be a kind of average, which is going to be very correct, but completely boring. So in the artistic domain, it's kind of almost exactly the opposite of what we want in the more serious social, well, art is social, but in the other domains. So I would say that the more bias there is, the better. The more ill-defined, the better. The only thing that counts is that you have to have an artist that kind of knows what he or she is doing, what she wants, even if it's a bit vague and flaky. And so Stuart was talking about the cars and all that. It's interesting. I didn't think about that. But in fact, in art, we are trying to do exactly the opposite, let's say. We are not interested in removing bias. We are not interested in anything ethical. What does it mean to be ethical in art? Probably so you see, so please direct your question to Stuart. Well, I think he has left, but
I think in a way this is the answer I was fishing for. So you're saying, well, no, let's keep it scruffy and let's make it as scruffy as possible so that creativity can emerge, right? As opposed to having a lot of rules about ethical and behavior and all that, right?
No, so I can just add one thing because I'm interested in, especially in pop music. That is not experimental music, but music that you have on, top. That most people listen to, and there is obviously a trend in this music of everyone trying to do the same. They all have the same sounds. They all have very poor melodies, very poor harmonies, and so my hope, the reason why I'm interested in AI and music, for instance, is just because I hope and I think that AI can help these people doing things which are more innovative, more audacious, more different. They don't. So that's my hope. That's the only reason why it would be interesting to try to develop these tools. It's not to help people do more of what they already do. I mean, if you talk about AI helping people making bad music, don't worry. There is already a lot of people doing bad music. Actually, you have millions of them. So you don't need AI to help them. It's not going to be worse. It cannot. So I'm not worried about the bad effects of AI here. I don't see how it could, be the case. Let's say.
Maybe I can jump into this discussion. Very, very, very interesting. At first, a meta comment. What Fabio calls scruffy and neat. Neat is kind of, remember in my introduction, just for the audience to make the connect the dots. What I call this, not me, just symbolic AI is more or less what Fabio calls neat AI. That is provable on logic, etc. And a sub-symbolic, remember in orange and not blue color, would be this scruffy. The point now I want to make, Fabio, is that for instance, using deep learning for instance, deep back, who creates back chorales almost like the original, but just as François said, it does it very well. But in a way, it's what's the point? I mean, what's the point to resurrect, Bach, to make more chorale in the style of Bach? it's not very not very creative. So actually, what you call the scruffy, more precisely, artificial neural networks and deep learning, actually they are very good at capturing learning distributions. And from this distribution, they could regurgitate, they could generate things within this distribution. But it's exactly the opposite of a creative act, because in a way they tend to do something very, very, very conformant to the originals, which is good or not good depending on the objective. And of course, the community of this deep learning for music generation is creating incentives for exactly us getting outside of I'm looking for my word as well, like François did. The comfort zone, and also, for instance, there are generative adversarial networks, and there are different techniques. François has been working on trying to put a sense of direction, because usually this music, after a few minutes, is boring because there's no structure. This is a big issue in making music in an automatic way. So anyway, just to say that it's scruffy is not necessarily the most appropriate, and so things are more complex, as François said.
No, I think it's something to study, something to be open. It was very nice to see the answers. Unfortunately, I must say I have to leave at 5, so I'm already late. So I'm saying bye-bye.
Thanks a lot.
And thanks a lot. It was really
Fabio.
a pleasure. Thanks a lot. Muito obrigado. Bye-bye.
So, Anna Cristina, Priscila, Stuart, I think Stuart, do you have any comment? Because it's 10 o'clock. So it's 3 hours, but just 1 or 2.
The small comment, François, it was an excellent presentation.
This is a comment.
No, it was really nice. I like it, and I hope we had more time to discuss. Just a small comment. Bias. Any system, any AI system will be biased. The problem is we need to get the bias that is okay in the society. So it's not that there is no neutral system. And about the music, and this is what I want to ask you, is like, you want to have a biased music generation, like I'm inspired by Bach or whatever, but you cannot exceed some limit, otherwise you have copyright problems, right? So can you
the pledge. So yes, it's a subject we have been working a lot on plagiarism, and it's true that. So I mean, okay. What is the question? So first of all, with AI, you can now detect cases of plagiarism. I'm not saying you can detect all the cases, because plagiarism, by the way, is a very interesting problem, because it's not completely well defined, in the sense that, as you know, it's very interesting to look at the trials. You know, when an artist is accused of having stolen a song, for instance. So there have been trials for many years. Some of them are very well known, like the one with George Harrison, a song which was accused and actually convicted of plagiarism. But when you look at how it works, it's basically experts listening and making a decision, which is a human decision. It's not based on like number of notes divided by whatever. There is no very precise criteria. So plagiarism is something that is basically a social consensus. It's not, let's say, a grounded, very explicit feature. So with AI, you can now detect some cases of plagiarism, which is good, because you can imagine systems in which you can make music, and that over the shoulder you would have a kind of indication. Hey, what you are doing currently is very, very close to what. But then, hey, what this is very, very new, or that kind of information could actually help and could be could completely change the way that people design creative tools. You can think about this also about the text. You can imagine you write a text, and then the thing that, hey, this sentence you just wrote has been written 2 million times, or this thing has never been written, you know, or something like this. So that would be really fun to have the ability to play with that. So I see plagiarism detection as not as a problem, but as an opportunity to give people the possibility to play literally with the what the others have been doing, right, in completely explicit ways. The second thing I can tell you is that I don't think that there are artists who are willing to create a work of art which is plagiaristic. It's very bad to be accused of plagiarism, and it is very bad actually. So the artists, they don't want that. So when they do it, most of the time it's by chance. It's not there because they really wanted to. And so now with the AI, what you can imagine is tools to help people be sure that they are doing something new, you know, and that's a very big opportunity.
But then goes to my last question is about exactly what is new, because if you look at the music, I'm not a musician, but if you look at the transition of music, and you are always thinking that, you know, the next generation doesn't understand about music, and they are, you know, producing crap, because this is, I'm not saying that you are old, but probably, you know, thinking about the generation music and, you know, and have an opinion has to do with our generation. So what we like, so what they are producing doesn't seem more like music. So, and this is very creative. People, this is how the music has been evolved. It's not saying that the old is not good, but also the new might also be good, but it's more like a revolution in the style of the musician. So do you think that the AI that you, Spotify are doing can go to some revolutionary music, or is going to be inspired of something previous?
Yeah, I mean, again, this is not the domain I'm able to predict what's going to happen. I can just say that we are building tools to help people do new things. Whether these things will be good, not good, popular, not popular, it's completely unpredictable. But I'm convinced. I mean, what I know that there are more and more artists out there. There are, okay, I don't know how many times more, thousands of times. In the 70s, or I mean, if you compare number of artists today to like what it was 20, 30 years ago, there is no comparison. So obviously, more people are making music. The tools are more powerful. It's easier to make music today than before. So obviously something is going to happen, you know, in terms of new music styles, and I think that AI can help. I'm convinced of that. Help people doing new things, and I'm not worried at all. But not at all. I am also partly a musician. I'm not professional, but I don't even understand the worry. I don't understand what it's about. I mean, I understand that the media needs stuff to talk about, but honestly, the only thing that's out there is just an opportunity to make new things, and that's what the artist, what we met, that's exactly what they want.
And what the AI should be for, to empower people. Sorry.
Yes.
Yeah.
Thank you.
And I think we have to close because we're already late. But I'm sorry for that. We didn't have time to answer all questions. Also from because we would need more hours. Also, as Martin put it, for AI and ethics, that in a way the panel discuss more questions than answers as well. But this is true. But in a way, science is about identification of questions. Actually, even more important than answers. So actually, personally, I adored this panel. I really felt completely hypnotized. It was a great pleasure be there. I hope for all the audience as well. I would like to thank a lot again the participants staying so late, also more than 3 hours, and debating. Of course, we would like to continue, but we'll maybe try to do it again in another time. I would like to thank again Anna Celia for setting up this great conference. Iago for mediating the questions, translators, and I think that's it. Thanks a lot, and see you soon.
Can you have the participants open the video, please? Please, can you open the videos? Yes.
So is it the transmission continues still, or?
Yes.
Yes. Okay.
I cannot open my video.
Yeah.
No, why not?
I don't know, because não é possível iniciar o vídeo. Você não pode iniciar seu vídeo, pois o anfitrião parou o vídeo. Ok.
Mas espera aí, Maculan, pode sim. Robson, por favor. O vídeo do
ele já autorizou novamente. Ele tinha realmente bloqueado.
Né? Então, Maculan, por favor.
Pronto. Ainda não.
Ainda não?
Mas bom, nós estamos ouvindo você, Nelson.
Eu sei, mas agora saiu.
Finalmente, que bom.
Então, por isso, hashtag.
Não, eles proibiram que eu entrasse, me fizeram que eu falasse. Tá bom. Não, don't worry about it. Just work.
Foi excelente o painel, muito bom.
Muito longo. Para velho como eu, está muito longo.
Muito longo.
Bom, thanks a lot, but I think it's
não conseguimos ouvir a Priscila, que é muito ruim não ter ouvido.
Pois é, Priscila.
Na próxima vez.
É por causa do tempo. Aí o Jean-Pierre conversou comigo. Então,
tá certo,
mas a gente vai organizar, eu vou organizar só para meu tema.
A Priscila é titular da Cátedra de Inteligência Artificial, de tal maneira que ela está organizando vários painéis maravilhosos, interessantíssimos. Nós vamos ter condição, né? Vamos ter exatamente a possibilidade de ouvir e organizar outros painéis no âmbito da Cátedra de Inteligência Artificial, da qual ela é titular. Então, muito bom.
Obrigado, Priscila, por entender que realmente tivemos que fazer uma escolha entre deixar o debate fluir, mas como você falou mesmo, vai ter muitas oportunidades dentro do seu seminário da cátedra, e você tem oportunidade para falar, para perguntar, comentar, que acho que então.
Não, ela perguntou, ela participou.
Mas bom, eu acho que talvez vamos finalizar o YouTube, tá?
Jean-Pierre, es-tu à Paris maintenant?
Oui, je suis à Paris.
C'est très bien, hein, c'est ça. Parfait. Tant mieux.
Ô, Robson, você pode parar a transmissão?
Acho que Robson, você pode...
a transmissão, por favor.
Bom.
Mas podemos